Welcome, everyone. Thank you, Jim. Thank you, Cynthia and Susan, for organizing this. So my name is Henrik Selin. I teach in the Department of International Relations here at Boston University. The other two people here at the panel is Noelle Selin, who's an assistant professor in atmospheric chemistry over at MIT, and Kristin Sippl, who is a PhD student in the political science department here at BU. And what we're going to do today is that we're going to use the very brand new Minamata Convention on Mercury to talk a little bit about the convention itself, but then also specific challenges relating to managing mercury. So I'm going to start off by giving you a very brief introduction to the convention and what it's trying to achieve. And then Noelle and Kristin will dig deeper into two key areas of both the convention and mercury abatement. Noelle will talk about atmospheric emissions and transport, including some of the science. And Kristin will talk about mercury use in artisanal and small-scale gold mining. So mercury is, of course, a heavy metal. It is naturally present in the Earth's crust. And humans have known about mercury for millennia. Mercury mining goes back at least 4,000 years. At least one effort to try and compile the many different in which mercury has been used came up with at least over 3,000 known uses of mercury over the last 4,000 years. Over the last couple of decades, however, mercury use have gone down. Now, the traditional way to then garner mercury is to mining of cinnabar. And throughout history, there have been a couple of really large mercury mines in Europe, in South America, and other places. But in 2005, we were down to a mere 3,800 tons of mercury that was mined. That might seem like a lot, but in a historical perspective, that's a relatively small amount of mercury being mined. Almost half of that comes from East and Southeast Asia, and in particular, China. China is by far the country that have the largest current mining of mercury. Now, one of the reasons for why mercury has been used in so many different products and ways is because originally it was thought to be a perfectly harmless and even beneficial substance. But we now know, of course, that that is not the case. The reason why it's called the Minamata Convention is that it sort of pays respect to the victims of Minamata disease in Japan, where there was a local factory that discharged high levels of mercury into the local bay, which then people consumed the fish, the seafood from the bay, got poisoned, and there were many instances of death and severe neurological illnesses. So we know that at very high concentrations, mercury is lethal. But what we've also come to know and recognize is that even sort of much more low-dose exposure to mercury over a longer period of time can cause problems. Typically not resulting in death, but in severe developmental delays, neurological damage affecting muscles, the brain, and so forth. If you are not directly handling mercury, and if you don't live next to a major point source, then most of our exposure is through fish. It's through our consumption. So that means that the next time you're thinking about interacting with creatures from the sea, it's not just about social stigmas. It's also about how to deal with mercury issues and mercury exposure. Now, atmospheric emissions is of considerable significance, and Noelle will talk more about that. I can just say briefly, though, that emissions into the atmosphere comes from three sources. They are either natural sources, as in volcanoes, for instance. It can come from re-emission, as in once mercury is released into the environment, it tends to cycle, and it can take over 2,000 years before it returns to the sediments again, which means that it cycles over and over again, which means that you also, in addition to new natural emissions, have a significant re-emissions from natural sources. And then the third one is then human sources, anthropogenic sources. And the Minamata Convention, for obvious reasons, only target human sources, anthropogenic sources, as in you can't really regulate volcanoes. They do whatever volcanoes want to do. But even through sort of human activities, we have released a significant amount of mercury over the last 4,000 years. One estimate puts it at about 350,000 tons. Now, today, as in 2010, 2011, if we look at emissions, that means that most emissions entering into the atmosphere these days are still coming from natural sources, including then re-emissions from earlier sources. So one estimate, and one thing I want to say, and Noelle will talk more about this, that there is a fair amount of uncertainty around the data here. But one estimate puts it a little over 5,000 tons every year going into the atmosphere from natural sources, while two different estimates from anthropogenic sources puts it either at about 2,300 tons or about 2,000 tons or thereabouts. But that's, you have roughly the ratio between natural sources and human sources there. Now, if we then take those 1,960 tons, which UNEP estimated in its most recent report that was out a couple of weeks ago, you get a pie chart that looks like that. So about, in that estimate, 37% of mercury emissions come from artisanal and small-scale gold mining, which Kristin will talk about, and 24% comes from coal combustion and major stationary sources, and Noelle will talk more about that. One thing that is new with the UNEP assessment, it is really the first assessment that puts artisanal small-scale gold mining ahead of coal-fired power plants. Earlier assessments have generally estimated that emissions from coal-fired power plants outweighs that from artisanal and small-scale gold mining. So we now have a new convention, and this is the result of a political process that has been going on for over 10 years. So in 2001, UNEP, the United Nations Environment Programme, initiated a global mercury assessment. And that mercury assessment came back about a year later and said that there was, in fact, a global problem related to mercury and mercury emissions and mercury use, and suggested some kind of international response. At that time, there were some countries, mostly the European Union and some developing countries, that pushed for a legally binding convention. This, however, was opposed by a number of major influential countries. The United States did not want a convention, Canada, Australia, China, and India. And since we're operating on consensus here, that meant that the only thing that they could agree on was to have a voluntary mercury abatement program, voluntary effort to reduce emissions and use. Now, the UNEP Governing Council meets every 2 years, and basically every 2 years we had this discussion, and it didn't really, the political momentum didn't really change until in 2009. And if we're, it's always dodgy to look for one single trigger, but if we are looking for one single trigger, I would say it was the change in the position of the United States. As in, this was after the Bush administration left the White House and the Obama administration moved in. And one of the first things on global environmental politics that the Obama administration did was that it removed its objection to an international treaty. That triggered then Canada and Australia to reassess their position, and then enough political pressure was put on India and China that there was general agreement to start negotiating a treaty. And we have now been doing that, well, other people have been doing that, between 2010 and 2013. So the convention was adopted in Geneva in January, and it will formally be signed at a meeting in Minamata in October. Normally, these things take about 2, 3, 4 years for a convention to enter into force. It's going to need 50 ratification, which means that it will probably enter into force circa 2016, 2017 or thereabouts. Now, I'm not going to go through the convention paragraph by paragraph. We don't have time, and it would be fairly boring. So I'm just going to highlight 5 major areas of the convention. One is then supply and trade. So the convention, the Minamata Convention, regulates the supply and trade in mercury in different ways. One of the things that it does is that it bans the opening of new mercury mine. But it gives parties that have mercury mining going on right now at least another 15 years before they have to phase out existing mercury mining. Right now, there is only really one larger mine in the world that is used primarily for export, and that is in Kyrgyzstan. And Kyrgyzstan is already working with the United States, Switzerland, and various UN agencies to close that mine. Most other mercury mining then in the world takes place, as I said, in China and a couple of other countries like Chile. As far as we know, most of that mercury is, however, used domestically. It's for domestic purposes. But still, you can trade mercury. Now, one of the things that the convention does is that it sets out what is known as a prior informed consent procedure, which means that in order to export mercury from one country to another, the importing country has to provide prior written consent that it consents to the mercury entering its borders. Now, some countries, including the one we're in now in the European Union, have already unilaterally instituted export bans. And countries can also set import bans if they want to. That is entirely voluntary. But for all trade, you have to go through the written consent. Importantly, it regulates trade both within parties, but also between parties and non-parties. So if a party is exporting to a country that has not joined the Minamata Convention, they have to demonstrate that they have the resources to deal with the mercury, to protect human health and environment, and have safe uses and storage. And also, if you are a party, you can import from a non-party, but only if that country can guarantee that it comes from allowed sources. There is a notification requirement that waives this, but only up until the second meeting of the Conference of the Parties, so that might change. But it sets regulation on both the supply and trade. Moving forward, another area, major area, is products and processes. Now, this is fairly complex. But briefly, what it does is that for 9 major products, like batteries, switches, measuring devices, as in thermometers, barometers, those kinds of things, the manufacturing, import, and export should cease at 2020. Now, countries can ask for exemptions for that, 5 + 5 years, which means that you can extend that up till 2030 if you want to. It identifies dental amalgam as an area, as a product that is subject to some restrictions, and there are suggestions for countries that want to phase out the use of dental amalgam, but it doesn't ban it, and it doesn't force countries to do that. And it also explicitly allows mercury use in 5 different products, including for military use, research, and so forth. And one of the more controversial ones was a vaccine you can use. If you add a small amount of mercury to a vaccine, that removes the need to refrigerate that vaccine, so you can then use it in warmer climates. Mercury is also used in industrial processes. In 2 of the major ones, that should be phased out. They have 2 different deadlines in 2018 and 2025. Again, you can extend that for another 10 years if you want to. And then it targets also a couple of other industrial processes. I can talk more about that if that is something that you're particularly interested in. The third major area, which Noelle will talk more about, is atmospheric emissions from major stationary sources, primarily coal-fired power plants, but also others. Now, for new sources, as in sources that are built tomorrow and into the future, you have to apply technical standards getting the mercury out of the chimney before emissions goes into the atmosphere. It is slightly more lenient on existing sources. Parties should take some kind of action within the next 10 years, but they have a slightly more a broad range of opportunities to do that. And finally, the convention also covers mercury releases into land and water from various point sources. So it is sort of covering all the media. So it regulates emissions into air, into land, and into water. The fourth major area is then artisanal and small-scale gold mining, where the ultimate goal is to reduce and, where feasible, eliminate the use of mercury. Now, so the target here is mercury use in gold mining. It does not target gold mining per se. It doesn't restrict gold mining. It restricts the use of mercury in gold mining. And countries that have more than insignificant artisanal small-scale gold mining, that more than insignificant is not identified, should develop a national action plan to address that, set reduction targets, and other measures that Kristin will cover more in detail. Now, the fifth major area of the convention has to do with resources and compliance. Now, there is a funding mechanism. There's something called the Global Environmental Facility, which is the main funding mechanism for environmental conventions. That is linked to the Mercury Convention, so money should be provided for implementation projects. They are also setting up a treaty-specific fund. Developing countries pushed hard for mandatory contributions to that fund. Industrialized countries refuse to do that, so we are stuck with voluntary contributions to that fund. But that means as a developing country looking for assistance with implementing and mercury abatement can go either to the Global Environmental Facility or the treaty-specific fund. Parties should also cooperate, especially industrialized countries working with developing countries, around capacity building and technical assistance, not least when it comes to artisanal small-scale gold mining. And they have set up a committee that promotes implementation, that assists parties, address compliance issues, and no later than 6 years after entering into force, they should also start periodical reevaluations of the convention and what parties are doing and if we are moving in the right direction or not. So we will all address the last question here: is this an important new convention? My take is that at least initially, it is more legally and politically important than it is environmentally significant. As in, it creates a new international agreement, it strengthens international law, and it clearly, from a political perspective, identifies mercury as a significant issue on a global basis. However, for most of the requirements in the convention, they are relatively modest. If we're looking at the next 5 years, or maybe even 10 years, it will have a relatively small impact on the use and releases of mercury emissions. That means if we are looking at this from an environmental perspective and from the longer range future, that means for this to actually become a truly environmentally important convention, the parties need to move beyond the existing mandates. They need to strengthen regulations virtually across the board. This is possible, like to look at the glass as half full, but it does require overcoming significant political differences, right? We have a relatively weak convention up front because that was the only thing that they could agree on. Now, since most of mercury emissions and mercury use is currently within developing countries, then this requires working on financial resources, capacity building, technology transfer, and those kinds of things. I'm going to turn it over to Noelle, and she will talk more about atmospheric emissions and transport, and then we will segue over to Kristin.
All right. Thanks, Henrik. So what I'm going to talk about is sort of a different perspective on the mercury issue. I come at the mercury issue from more of a scientific perspective. My research looks at how mercury travels from place to place, what human activities and human emissions of mercury, what importance they have in the global cycle of mercury, how the pathways from emissions get to human impacts. So I'm going to give you a little bit of perspective, first of all, on some of the different forms of mercury in the environment, how they interact, how we can think about the past sources and the present sources in context, and also how we can think about what would happen in absence of the treaty in terms of trajectories for the future of emissions, and then what might likely happen as a result of the treaty. So just to reiterate why mercury is a problem, I think one of the things I wanted to mention from a science side is that mercury is a problem in general, but when mercury deposits to the aquatic environment, it converts into a form that's even more toxic. So the mercury that, for example, is in dental amalgam is the silvery liquid form, elemental mercury. But the mercury that's in tuna fish is methyl mercury, and methyl mercury is much more toxic. So there's differences, and there's the natural environment mediates this transition from mercury to methyl mercury. It comes from biological activity. Bacteria, sulfate-reducing bacteria can convert mercury into methyl mercury. So this happens in the aquatic environment. So what we're concerned with is how does the mercury get there? How does the mercury get to the open ocean? And it's basically through global transport. So from a scientific perspective, why is this a global problem? Why do we have a treaty in the first place? And that's because mercury can travel globally. It lasts for a long time in the atmosphere, 6 months to a year. So think about if something emits into the atmosphere, it takes about 7 to 10 days to cross an ocean. And mercury lasts for about 6 months. So you can think of it as sort of blowing around the whole globe and mixing. So by the time it rains out into the oceans, you're looking at the signal of pretty much all of the global emissions of mercury mixed up together. And so you're really looking at the combination of some local impacts, and Kristin will talk more about for example, some of the impacts in gold mining communities, and long-range impacts. So mercury is of particular concern in the Arctic because the long food chains there allow methyl mercury to bioaccumulate. So posing a danger to consumers of seals and other high marine food chain foods, like polar bears and like people in the Arctic. And this is also a problem in the United States. Just to give you a magnitude of this problem, the EPA gives advice, particularly to pregnant women, on what kinds of fish they could eat that are safer with respect to mercury. And it's estimated that about 300,000 newborns in the US each year are at risk of learning disabilities due to elevated mercury exposure. Most of the fish that pregnant women and a lot of other people in the US eat come from the open ocean, like tuna. Not necessarily domestic fish, although domestic fish are a problem as well, and I'll talk a little bit about that. But in order to deal with this problem of these 300,000 newborns in the US, you really need global action because the sources of that mercury exposure are coming from everywhere. So that, from a scientific perspective, is one of the bases upon which the treaty is based. So also, one of the key impacts of mercury is, again, in the offspring of pregnant women, neurological damages. I just wanted to mention that those of you who aren't in that category, males, you're not off the hook because mercury has been linked to cardiovascular impacts as well, so heart attacks. And so that might be something that's closer to your experience. So everyone's pretty much in the same boat here. And so what's happened in the present day versus the past in terms of mercury levels? And I'm taking this figure from the Arctic Monitoring and Assessment Program. It basically shows what mercury levels look like in the Arctic all the way back to 1200. And basically this gives you a sense of what's natural and what's anthropogenic. And in contrast to the policy definition of natural, which Henrik talked about, which is, well, natural's kind of anything that we can't worry about directly. As a scientist, I define natural in a much more confined way. And natural really is something that isn't affected by humans. And most of the mercury, something like our models are showing something like 80% or more of the mercury that is circulating through the environment has been affected by humans in some way. Now, it might have been affected by humans in the 1200s, in the 1500s, in the gold rush, but it's human rather than volcano natural. So that's really shown by this diagram here. That since the Industrial Revolution in the 1800s, it's basically a factor of 10 in mercury in these biological species in the Arctic. So that's human teeth, beluga teeth, ring seal teeth, polar bear hair. The levels really have increased dramatically. So that's a pretty strong signal that humans have done something to the mercury cycle. And so the reason that we're looking at this is because these global sources are pretty well mixed. So I'm showing the same figure that Henrik showed earlier, but that just to give the point that because mercury is so well mixed in the atmosphere, this is pretty much the signal that you would expect to see if you went up and measured mercury in the air in a lot of places, particularly far from direct sources. You would see a mix that looked just about like this. And I'll talk about some of the science that complicates that matter a bit, but to a first approximation, this is what's raining out in the open ocean. So you can say that coal and artisanal small gold mining are a large contributor to the present day loading in remote areas. So again, why global negotiations from a US perspective? And this gets into a little bit of the more complex science behind mercury. So this comes from some of my modeling work using a global scale model of mercury emissions, chemistry, and transport and deposition in the atmosphere. And so one of the things we find is that looking at mercury in the US, we have a regulation for mercury emissions. It's called the Clean Air Mercury Rule. And that regulation came out about a year ago, so last January, December timeframe. And that regulates mercury from coal plants, requires technologies to be placed at the end of pipe to reduce mercury emissions in the US. And why is that important if I'm saying that, that mercury is pretty much a global problem? And that's because mercury is odd in a sense, it's because it's both a global and a local problem. So you might think of something like climate change, for example, where carbon dioxide emissions, it really doesn't matter where you emit it, because a molecule of carbon dioxide has the same global warming potential wherever you emit it. That's not the case for mercury, because mercury can be emitted in a couple of different forms. It can be emitted in one form that actually rains out pretty close to power plants, or pretty close to sources, and one form which circulates in the environment. But remember, mercury is also an element, so you can't get rid of it. So once it deposits to the ground, it can then pop back up again and enter the global cycle. So a lot of the scientific research that we're doing is trying to figure out, what timescales does that operate in? How do we understand that near term versus the longer term versus the long future ahead? So this is, and how does that intersect with the timescales of policy? So this figure really shows that, that happening. So if you look at where mercury is depositing in the US, actually the highest mercury deposition total is in the southeast in Florida. So what we did with the model here is we said, what percentage of that is coming from US sources? And so in the southeast US, we see only about 15 to 20% coming from US sources. Whereas downwind of the major coal-fired power plants in the Ohio River Valley, which is basically us, we see a higher percent, almost 50 to 60% in places coming from US sources. And that's because those plants emit a combination of the mercury that enters the global pool and the mercury that deposits quickly. So that kind of analysis really tells you that if you want to deal with the mercury problem locally in the entire US, you really need a combination of the local and global impact. So when you look at the US mercury deposition, talked about, you can think about 2,000 tons of mercury emitted every year to the atmosphere. Roughly 100-ish is from US sources. So US is a small percentage of the global pool here. And that's surprising to those of you who look at sort of environmental issues potentially, but one of the reasons is that the US has implemented a lot of more traditional air pollution regulations on emissions that have had a co-benefit of cutting emissions from mercury. And that's the case in the US and in Europe as well. So the US used to emit a lot more mercury 10, 15 years ago. The US does have mercury regulations as of the late 1990s on municipal waste incinerators and combustors and medical waste incinerators, and that controlled a lot of the mercury emitting. And then those traditional regulations on air pollution that came in. So if you look at US mercury emissions over the last 10 years, they've gone down quite a bit. And in the context of a global negotiation, this really shows that these kind of restrictions are feasible and something that countries might be able to put in relatively quickly. Again, we're not looking at something like climate change where the US and Europe are struggling to figure out how to do it. These are well-known technologies. It's just a matter of implementation and will to do it. So one word about sort of the cycling of mercury in the environment. A lot of our work looks at how to understand how mercury cycles and what the relative importance of natural sources and anthropogenic sources are. And this just gives you a picture. The red arrows are the purely anthropogenic fluxes, and the black arrows are the purely natural fluxes, and then the red and black dotted arrows are just looking at how those fluxes are present even in the natural case, so a millennium ago, but they've been enhanced by human activities. So even these sort of what seem like natural processes from a policy perspective, so exchange of mercury between the atmosphere and vegetation, exchange of mercury between the atmosphere and ocean, are in fact influenced to a large degree by human activities. So a lot of these flows come from human-released mercury from the past that are continuing to cycle. And the important thing is that there's a lot of timescales inherent in this diagram. So mercury will last in the atmosphere for a half a year to a year, but then it'll hang around in the soil and the surface ocean and then pop back up. So that extends the amount of time that mercury is kind of available to be picked up in fish. And really the only way you get out of this is that bottom right of the diagram, going back into the deep ocean and settling. And you can do a few calculations based on this diagram, but we're talking thousands of years. So this is very much the longer range future and well beyond the capacity of treaty making, even on that slow time scale, to deal with. So the key to that from a policy perspective, if you flip that around, is that each atom of mercury that you prevent being emitted into the environment then will avoid that near-term and longer-term impact. So it gives you a larger benefit as well as a larger cost. So some of the latest science is actually talking about these long time scales. And again, we used to think that about a third of the cycle was natural, a third was re-emitted, and a third was anthropogenic. And recent research, in part from a group at Harvard School of Public Health, is sort of taking into account that this might be an overestimate, and trying to understand how much is actually natural and how much is this really long time scale. And the 2013 mercury assessment is really changing the way we think about mercury emissions to the atmosphere. In particular, that artisanal and small-scale gold mining was a bigger chunk than we thought. From a scientific perspective, those of us who model mercury in the atmosphere really have focused on the emissions piece of it, the direct atmospheric emissions. But when you look at total quantities of mercury, the amount of mercury in products and the amount of mercury that's mined really dwarfs that. So how much of that enters the kind of diagram that I showed before is really an open scientific question. So what's the importance of that in terms of getting all the way to fish? Again, there are risks because people are exposed directly to that, but what is the environmental implication of that? We still really don't have a clear picture. And so just to go over what's happening here in the last couple slides on emissions in the Minamata Convention. The Minamata Convention separates emissions to air and releases to water and land. So when we say emissions in the context of the convention, we mean just emissions to air, and releases is the word that they use when you let mercury go to water and land. Again, there's a 5-year delay for new sources, a 10-year delay for existing sources. Now, Henrik estimated about 2017, let's say 2020, for entry into force. So we're looking at 2025 for new sources and 2030 for existing sources. So when you think about the trajectories of mercury emissions in the future, that means that maybe some countries will do some planning, but in terms of actual requirements, bending the curve on emissions, you can expect 2025 and 2030 to be the times when that anything due to the treaty will kick in. And one of the reasons that's important is this figure that came from a paper that I recently co-authored with Elsie Sunderland from the Harvard School of Public Health. And this comes from a Harvard graduate student, Helen Amos's work. So this is a picture of anthropogenic emissions under 4 different emission scenarios in 2050. So about 2,000 tons now, you can see on the very left. That's about the estimate from 2008. And depending on your scenario of the future, you could be up to about 4,300 or down to about where we are today. So under business as usual scenarios, we're really expecting that mercury emissions would increase. And so if all mercury emissions were cut to zero, which of course is not particularly feasible, but that gives you a bounding, the change in atmospheric emission, in atmospheric deposition would be quite substantial, both from the primary pool and from the legacy pool, because again, that's sort of feeding into itself. The primary mercury that we're emitting today becomes the legacy mercury of tomorrow on these kind of timescales. And that's the case for each of those scenarios. The change in atmospheric deposition is increasing, but increasing much worse in the highest scenarios. So in a sense, the message from this, and the message I want to give you, is that, so first of all, the mercury problem globally, without the treaty, is projected to get much worse. And if the benefit of the treaty is to take us from that 4,300 emission future to maybe the present day, depending on the willingness of countries to adopt different technologies, that could actually have a strong influence on the potential future mercury deposition. But again, we wouldn't necessarily see that reflected as a decrease in environmental damage from mercury. It's really preventing a lot of future damage. So that's a bit of a complex point, so I'm happy to answer questions. I do also want to say that I did get the opportunity to present some of the scientific work to the fifth negotiating session, the fifth and final negotiating session, which was last month in Geneva, along with 10 graduate students from MIT. And this was something that really resonated, I think, with the delegates there. Everyone was really very much convinced that we have to do something about mercury. So there was broad agreement, and it was a really beneficial thing to get to the table. So with that, I'll kick it over to Kristin to talk more about artisanal mining.
Cool. Yep, I'm Kristin. It's really great to be here. I'm a PhD student in the poli-sci department here at BU, and I just want to thank the Pardee Center for having me, and Henrik and Noelle. This is one of my favorite things to talk about, and it actually ties in really well to my dissertation research on the governance of global supply chains. So really, the story about the global mercury problem and then the problems associated with the global gold supply chain, it's very important for both academics and policymakers to understand. So even though we've been talking about mercury this whole time, I'm going to start out talking about gold. So here we are. Everybody knows we've loved gold. Humans have loved gold for thousands and thousands of years, but we don't really know that much about it. The everyday person doesn't know where all of this gold is coming from. And we usually don't know exactly where it's going. So for example, I was surprised to find out that about half of the world's mined gold supply, the gold that's taken from the ground each year, about half of it actually goes to the jewelry industry. So of course we wear that jewelry, but sometimes we also buy it for investment too, especially if we live in a country where banking systems aren't as developed, which could be here. But yeah, so it's also a great store of wealth. So that's a half of the gold. A third of the gold goes straight into bullion, where it's traded on the international financial markets. And then only a small part really is used for electronics, which was surprising. It's about 10% actually goes into devices like cell phones. And so usually when we think of where it all comes from, now that we know where it goes, we usually think of large-scale transnational firms, taking huge bulldozers to mountaintops and hacking them off. But really? About 30% or up to a third of the world's gold supply comes from scenes like this. So these are the about 15 million small-scale and artisanal gold miners who are mining in mostly developing countries, and they're doing this just to earn enough money to live on. So these people are picking up this job as one of several small-scale livelihoods, like farming, having small market sales at the end of their street. They're doing this seasonally as one of several to make ends meet. So it's not very hard to do this. Just about any of us can. If we live in a region that is gold rich, or we can migrate to one, basically, and I'm talking about jungles, right? So this is taking place in tropical forests, rainforests, or in river deltas. So these are really environmentally sensitive regions. But if we can get there, all we need is some very basic tools. This doesn't cost a lot of money. And of course, the central tool to gold mining is mercury. So this brings us to the treaty, right? So here's the connection. And as we've said a couple times now, 37%, the #1 leading cause of mercury pollution, actually comes from the processes used by these miners. So I'm going to walk you through the process really fast so you can see at what points in the mining process the mercury actually escapes into the environment. So the first step as a miner is you have to get yourself some mercury. Now, this can be a little bit complicated because mercury tends to be illegal to import for use in mining. One thing I didn't mention is that this mining, another reason why it's really easy to do, is that you don't need to require a permit for it usually. It's part of the informal economy. Most countries don't have laws regulating the small-scale miners. And then for the few countries that do have laws, they're usually not enforced. Very remote regions, these countries have capacity issues anyway. So this is very much a black market, under-the-table livelihood, unfortunately or fortunately. So buying the mercury for this livelihood is usually illegal as well. So how do they get the mercury? It's very legal, it's perfectly legal to import mercury for use in dentistry. Okay, so the mercury flows into the country, it's purchased by dentists or people in the dental industry, and then there are traders, either mining bosses or just people who do this for a living as a dealer, traveling salesman types. They buy the mercury from the dentists, and then they sell it at very nice prices for them to the artisanal gold miners. Okay, the miners don't do very well in this deal. They get exploited, but given their situation, which is in situations of poverty, something is better than nothing. So now they've got it. So what's the second step? Is they actually have to get some gravel, right? Some gold-laden dirt. So they go and dig that up, and then they grind it up. And step 3, of course, is taking that dirt and then pouring the mercury on top. So this is the really interesting part and the chemical and sciencey part. The mercury actually binds to the gold that's in that rock to form the silvery gold amalgam ball that you see right here. So some of the mercury binds to the gold, and then the rest of it is left over as waste. So this is where the releases to land and water come in. They take that mercury and they just ditch it over the side, right, onto the ground or into the waterway. So that's where it bioaccumulates up the food chain. And then the rest of the mercury in the silvery ball goes on to step 4. So this is where the releases to air come from. Okay, this is the 37%. So they burn the mercury over an open fire or with a blowtorch, like this guy is using, and the mercury vaporizes and goes into the atmosphere. Of course, it doesn't only go into the atmosphere. It also goes into the miner's lungs. Which is what Noelle and Henrik are talking about. This is the local pollution right here. It's very damaging for males and females alike to breathe in this mercury. Of course, it's particularly damaging for females to breathe it in. Females were at risk for damaging our fetuses. We're at risk for the children around us. So it's a really big public health issue in these countries. And women often do this part of the process because it's more skill intensive rather than requiring a lot of physical strength. So it's very common to have women doing the burning of the amalgamation. Step 5 closes it off. After you burn all the vapor off, you end up with a piece of gold, low quality. You send it off to a gold shop in town. They do one more burning. It releases a little bit of the mercury still to join that 37%. And then it gets sold on up the supply chain. So it goes to consumers in the US, in India, and then in the Middle East as well. Where is it happening? Quick and dirty, you can see it's in the global south. There is some in Mongolia, that's an exception. But these areas circled in red are basically the global hotspots. And it's kind of cool because thanks to research like Noelle's, we can see that when we go to the store and we get, or a restaurant if we have enough money, we buy a spicy tuna roll, we can know that about 1/3 of that, or a little more than 1/3 of the mercury that's inside that spicy tuna roll is coming from regions like this. So what is the international community going to do about the problem? This brings us to the convention. There are basically, so there's 2 articles that deal with this sector that deal with it directly, and that's trade and then the gold mining article itself, and then there's an annex which provides some details. So the first article is on trade, and this one, of course, we talked about the illegal trade of the diversion of mercury from the dental industry off to the miners. Some countries wanted to put in language about this to try to prevent it or at least start tracking that diversion, and then other countries didn't. They want to just leave it out. You can see who won. There's no mention of gold mining up there. All of the countries are required to do is the prior informed consent procedure that Henrik talked about. So there's no language on gold mining, but of course it still does affect them. The second article is about gold mining itself. And basically, if you have more than an insignificant amount of mining in your country, you need to reduce the mercury used in it. And if you can, depending on your geology and the amount of money or the amount of machinery you're able to afford, eliminate it. The major requirement on countries, just to get to the punchline, is that they have to create an action plan. They don't actually have to do anything. There are no timetables, but they have to say what they're going to do. They have to create a paper trail on this. So there are several steps that they have to take, and they're listed in the annex. But I think that the most important ones are the ones that I have here in red. The first is eliminating worst practices. So worst practices, that's that burning of the amalgam out in the open, right? Letting all the fumes go everywhere. Another one that some people falsely believe is better is mixing the mercury with cyanide. But all that does, yeah, you reduce the mercury, but really the cyanide mixes with the mercury to make the mercury more bioavailable to transform into methyl mercury, which Noelle was talking about as the most poisonous form. So that's no good. So we want to get rid of all of that. There's also a requirement to formalize the sector, which is a little tricky, and I'm interested in learning a little bit more about the details on that. But like we said, this is illegal. We want to try to get traction on this section, so it requires them to create a formalization plan so that it can be regulated. And then it also requires countries to create a promotional strategy. So how are you going to get the word out there that you can formalize and that you can do things in a different way? The key to those promotional strategies working, for me, is similar to what Henrik and I argued in the paper. It's going to be raising awareness among these communities and then transferring technology and doing that in ways that resonate with the communities. So awareness raising, that's the first thing. It's kind of surprising to find out, but a lot of the people in these communities, even though their families have used mercury in mining for generations, they're not really aware that it's hazardous for their health. We think this is surprising, but we need to remember the social context in which these people are working. A lot of times they're in remote communities. They're not literate, so information regarding mercury's health hazards, it doesn't flow, and when it does, they don't process it the same way that we might. So they don't know. They've seen people using it all their life, and they assume it's fine. But then the key is, these communities, yeah, they see a lot of sick people all around them, but there's also a lot of malaria in the communities. There's also a lot of sexually transmitted diseases. So these also present physical symptoms that are very similar to mercury poisoning. So it's really hard in this context to make the causal connection between the mercury and the symptoms that they're seeing and experiencing. So part of the promotional strategy is going to have to be making that connection so that miners internalize the cost of the practices that they're using so that behavior change becomes in their interest. You need that bottom-up demand. Once you've created the bottom-up demand, of course, you have to help them get something to change their behavior with, which is what brings us to the key technology that's being promoted in the treaty. And that's this thing called a retort. So the retort is supposed to get rid of all of the emissions to air. It basically puts a lid on top of, when we burn the amalgam, it puts a lid on top of that. The vapor consolidates on top, and it flows through a tube and gets collected into a bowl. So not only does this protect the miner and you and me from the health impacts, it also allows the miner to recycle the mercury. So it adds a financial incentive for them to use this technology in addition to the health one. There are a couple different types of retorts. There's a lot of trade-offs. This one on the right, super cheap. They can make it themselves with kitchen bowls, but it's also really easy to mess up the use and take the lid off too early, let the mercury go. This one up here is made by a firm and it's more expensive. Really easy to use, but like I just said, really expensive and it breaks really easily. So getting the right technology for the context, ones that they want, is really important as well. Then the final piece is the governance piece. We can make them aware of the risks. They can want and get the technology. But until you actually enable these miners to get a fair price for their work, they're not going to break free from the poverty situation that is driving them to mining in the first place. So if we want a long-term solution, we're going to have to think about regulation and formalization of the sector. This is tough, right? Because a lot of people don't want the sector to become legal. People who are winning from the black market conditions include the Mercury dealers, but also the miners themselves, which is surprising, right? So miners often don't want to legalize because it's going to be more expensive. They're going to have to buy permits. Then they're going to get taxed on their goods. And there's also the issue of the timing of the money. People in these situations need money now. They need to buy food for their family. They need to buy medicine. They want it now. They don't want to wait for permits to go through government bureaucracies. This is not in their interest. Even though theoretically they should get more money, it should offset these costs, it's not an easy sell. And then the other question in the miner's mind is whether or not they're actually going to get these permits at all. Because it's not in the government's interest all the time to give the permits to the small-scale miners. They want to give the land to the large-scale mining companies that'll pay the most for the permits, that'll pay a lot in taxes and royalties. So there's some troubling incentives there. You see this guy with a gun. There are a lot of conflicts between the large-scale and small-scale crews and the government, and right now they're usually being settled by force rather than in the courts. And then if we're finally, governments are aware of the Mercury problem if they're on board to actually write laws to change it. There's the issue of government capacity. Are they actually going to be able to project their force into these rainforests? In Colombia, gold mining is now taken up by the FARC, right, who's usually doing drug trades to fund their paramilitary operations. Now paramilitary groups are using gold. So this is very difficult to govern. It's not clear that the laws will actually be enforced. Which brings us, so they're going to need international community help, which brings us right back to the convention. Henrik talked about this. The financing right now is going to be through the GEF. And it sounds great. We do have an international program for capacity building. Again, the trick is that all of the funds that flow to this program are voluntary. So countries are going to have to pony up the cash if we want to actually address the #1 issue of mercury pollution. And then another part, a non-government approach from the private market and civil society is the fair trade gold movement. So this is something that, in case there's not a lot of cash that goes to the treaty, this is a movement that can kind of help complement it. Basically, fair trade organization is saying, miners, if you can legalize, organize, adopt cleaner technology, we'll pay you a fair base price and then some more on top to invest in your community. This is all well and fine, except for these guys are going to face the same set of obstacles that the guys working on the treaty are going to face, right? You still have to convince miners it's in their interest to do this. There's still a lot of obstacles. There's a lot of parallels between the two movements. So in conclusion, there's still a lot of questions that I have that are really interesting. Will the treaty make a difference, right? Yes, I agree with these guys. It will make a difference. It helps to get countries thinking about this, to get them writing it down. It creates a paper trail with which we can hold them accountable. But will it make an environmental difference right now? Probably not, right? There's a long way we have to go. But it's a good first step, and I'll be excited to see what these countries put in their national action plans. So that's it.
All right. Thank you. We, on purpose, left lots of room for questions. So questions for all of us, or one of us, or however you want to do it.
For the question, let me tell you, what an interesting panel. Nice experience. And we have some questions for you.
Questions?
Yeah.
Just a quick question. You mentioned about dental industry is used as kind of a smuggling mercury to the miners. But relatively dental materials, compared to those kind of mining scale, it's really small. So, it cannot really make up to the need of the miners, I guess. Could you just explain a little bit more
Well,
about that?
Yeah, I mean, that's one of the things that's going to be really nice about the treaty. Again, it might not actually change the amount of mercury flowing through the system, but creating that paper trail and doing the prior informed consent, we might actually be able to get a better sense of the numbers of how much is flowing to the dental industry. And if we see, oh, good God, 100 tons or something like that is flowing to dentist industry, and they only need, say, 30, we can start to see where's the rest of this going. At least that's the ideal. It may not work that way, but if we can partner with the dental industry a bit more to see how much you guys actually need and how much is being traded, hopefully we can get traction.
I mean, the individual dentists are probably not the source of the smuggling or whatever. It's going to be the industry, I think. Yeah. And then the industry is mostly located in the well-developed countries rather than those belt you showed. And somehow, I don't really see the chain really well connected.
Yeah. Well, it's a good point.
Secret, I guess.
Yeah, I was going to say that's a great area for more research. The trouble is that nobody really wants to talk about their black market deals. We'll try to tease out this chain. I mean, it's one of the problems with this supply chain. So that's a great question. Yeah.
Well, we are the dental bench. We work at the same school, so relating to dentistry. There's a lot of disinformation, a lot of this misunderstanding when it comes to mercury, because every child knows from the parents that you shouldn't touch mercury because it's a poisonous material. And obviously, used by, I think, who said it? Perhaps you, that there's all these forms of mercury, and the elemental form is not so upsetting, and that's what we use in dentistry. However, the elemental form doesn't get into the body through the tissues, it gets into the body as vapor. And that vapor occurs when you triturate the mercury and when you condense it. And when you take it out of a filling, because the burr running at 20,000 reverberations a minute creates a lot of heat, and that comes out. So what we were saying for ages in the dental industry is that the biggest, say, consumers of this vapor is the dentist and dental assistants, because they're always exposed to it. So the question is, why doesn't anything happen to them? There's two kinds of toxicity of mercury. One is acute, and usually it happens from the organic type, and not from the ethyl, but from the biethyl mercury. And that, I mean, when it's diethyl mercury, it's not even acute, it's immediate. You die from it in a couple of days and there's no antidote. So the fact that there is that kind of mercury and people read about it and there's stories, people do research with it, with double gloves and all that, if it touches the body, there's no way, almost no way to save the individual. So it already creates, a kind of a story of how bad it is for the body. When in fact, in dentistry, nothing is happening to the dentist. They have a longevity. The longevity of dentists is better than the average of the population, like any other professionals. The longevity of dental assistants, no one had done studies, but they couldn't find anything except in Sweden. They think that they have more miscarriages, but I don't know if it's causation or correlation. So really, there's nothing happening in dentistry, and that's why the American Dental Association is not against mercury. But it has a big impact in terms of consuming mercury. Dentistry is the third largest profession or industry in the country in terms of consumption of mercury in America, in other countries too. So in dental schools in Switzerland, the dental amalgam has been out of teaching for 18 years now. In the United States, if you say we're going to eliminate mercury, there's a whole faculty that's going to be against you and say, how are we going to teach? So many of these things are just like the human sense of getting used to something and you don't want to change. Now, I personally think that we should look into eliminating mercury in dentistry slowly because of the environmental impact. It's true that what Mount St. Helens did in 1980 had a bigger environmental impact than anything else we do, and it will occur again. But everything is additive. I don't think tuna 5,000 years ago had so much mercury in it as it has now. One interesting element, though, who said about people that eat a lot of tuna and disease and so forth. One of the countries with the longest life expectancy is Japan, and that is a country that consumes more sushi than probably any other place on Earth. So we don't know the correlations exactly, but we do know that salmon has almost no mercury and tuna has mercury. So the American Dental Association tells dentists, if you're going to eat sushi, eat salmon and only once a week. So these things, what I'm trying to say is that it's a very, confused story for the people that deal with mercury. The entire dental profession, 170,000 dentists in America, are not getting the true story. So to me, it's a revelation, to hear you talk. I didn't know about the convention. And I visited the UN in Geneva several times because one of my friends was an ambassador of a country there.
Did you want to respond?
Yeah, I did actually. So there are a couple of things that came up. One, having gone to 3 of the different negotiating sessions, one of the interesting things was to see the different dental groups. There were definitely dental groups who are pro-mercury and dental groups who were very anti-mercury. And this was one of those things that I think from a scientific perspective ended up being a little bit, it's a very technical issue. And it's interesting in the idea of communicating scientific findings to the public, because how do you explain to people that, okay, it's okay to leave in your mouth, but in a tiny fraction in a tuna, it can harm you. People don't really understand the different forms well enough to really understand that difference. One issue with dental mercury, again, the environmental impact. One of the substantial environmental impacts isn't actually in the vapor phase, it's in the releases. And what happens when the mercury comes out of the mouth and gets, if it's not disposed of properly, just rinsed down the drain. So one of the things we saw from a domestic regulatory context, actually specifically in Massachusetts, was that when amalgam separators were required in dental offices, again, there was a strong correlation, and we think potentially a causation in decreases in fish concentrations of mercury after several years. So that's one of the issues. In terms of the longevity issue, it's interesting for mercury because I think one of the issues with mercury is that it's not necessarily really obvious. It doesn't cause deaths in a way that sort of particulate matter causes deaths. It causes reduced capacity to learn, so that it's very difficult to actually see the effects. People might live just as long, but we can expect, based on studies that have been done, for example, with lead poisoning, that economic productivity might take a substantial hit. So, in the absence of mercury, you might see even more productivity, even more sort of capacity in your population on average. And again, this will differ. It's not a uniform distribution as well. So those kinds of issues.
And on the language in the convention, it's largely the WHO, the World Health Organization guidelines. So they were the ones that made the invention and basically support a phase out of mercury in dentistry, but is not demanding that they cease with it. And the same with the mercury in the vaccine. It's the same. They generally follow the World Health Organization guideline. So in terms of potential strengthening of the text in the convention, I would argue probably has to do whether the World Health Organization issue new recommendations or not. If they do that in the future, they will probably change the text accordingly. We basically punted and said, this is up to the World Health Organization. Whatever recommendation standards you set are the de facto the convention standards.
I'm just curious, science aside, how much do you think there's going to be a phase out of dental mercury just because of consumer pushback? I mean, I've worked at the basic science level with these autoimmune diseases and with rheumatologists who have their patients coming in with scleroderma asking for, mercury fillings to be removed. And is that something that, regardless of what the two dentist groups feel, that it's going to happen anyway just because of consumers?
Anyway, it's a very touchy issue because there's a lot of disinformation. The dentists to make money from it. The dentists, there's a whole group of dentists that claim that people with Parkinson's disease, when you eliminate their amalgams and put a different material, the Parkinson goes away. I've had physicians call me to ask me about their dad or mother with this thing. One of them was a toxicologist. So there's not enough knowledge, and obviously most of these things are bogus. But there's so many elements that are involved in it. In Sweden, that is a very developed country and all that, they go around crematoria and they measure the mercury in the air and they show you that it's 5 times as much as normal air. I mean, that's how much the mercury is really represented, and certainly in the ground. But the silver amalgam filling, which is it's a wonderful chemical thing because you take a powder and liquid and mix them, put them in a tooth, and within 5 minutes it becomes a solid metal. It's amazing. It's easy to do. So it's an economic issue. The world that doesn't have, the non-developed world, that doesn't have enough money, where dentists are doing their work under lesser conditions than here and want to do it very inexpensively, amalgam is the best solution. It's quick, and it does the job, and it stays in the mouth for 25 years without breaking.
So I think that's one of the issues that comes up in being a global treaty. So you might see that in the U.S. and you might see that in Europe particularly, and there also are potential impacts of the substitute. So that's something also to consider. But the issue, though, is that most of the countries in the world are not the U.S. and Europe, and in that case, what consumers are, as the countries are developing, they're realizing that dental care is actually an option. And you see populations in the U.S. as well with that. If the option is pulling out the tooth or getting a mercury filling, that's a very different kind of decision making.
Thank you. A quick observation, and then I have a question. One is that if we connect the two ends of the table here, is the global treaty, which lays out criteria for the exercise of some kind of control, versus the artisanal economic dimension, means that if you look at the map, where is the state the least powerful, least likely to have that effect? And so we have this built-in conundrum of looking for global solutions when the local actors are unlikely to want to participate. That's kind of an observation, but I think it's a very interesting one. The other one is maybe, Noelle, for you or for the others, what is an analogy for mercury? I was thinking of cyanide because it's used in gold processing on larger scales. But what is an analogy for something that works like mercury? If we think of diseases, there are some vector-borne diseases versus bacterial versus viral. And we can look for analogies between different diseases and how we might address them. What's an analogy to mercury, a similar kind of substance, a similar kind of problem that we might use to understand more easily?
So I think from a scientific perspective, there's a lot of similarities between mercury and persistent organic pollutants like DDT and PCBs. And you waved Henrik's report on that earlier, so I think I'll kick it over to Henrik to talk a little bit more about how on a political level. But on a scientific level, these are substances that also have both local and global impacts that we thought we could deal with on a local level that still pose very local problems, but that also can travel long distances and also have this multimedia behavior. Long lived in the environment, not forever like mercury being an element, but 20 to 50 to 100 years, sometimes resistant to degradation, hanging around in the land and ocean, popping back up. So scientifically, you have a lot of similarities, and that was talked about a lot in the treaty process. And Henrik, you can talk more about.
Sure. So there are a couple of ways in which the Minamata Convention is unique. It is the first global treaty to regulate a heavy metal, full cycle, right? So it's the first global treaty on a heavy metal. It's also really the first standalone major global environmental agreement in over a decade. That said, though, there are a number of older agreements on hazardous chemicals that regulates their production, their use, their trade, and so forth. That was now persistent organic pollutants, POPs, which then includes the DDT, PCBs, and so forth. So a lot of the legal work and a lot of the political work on these earlier chemicals agreements are now feeding, or did feed into the creation of the Minamata Convention. And there are definitely some lessons there, including on capacity building and technology transfer and funding because under those chemical agreements, you have the same conundrum as you have here. You have a global agreement, but the area where many of these substances are used the most and pose the largest threat is in developing countries that have the weakest governance structures. So in that sense, the conundrum for mercury is not unique. There are lessons that can be drawn, not altogether positive lessons, because not all of these agreements have been super successful. So it has helped us also identify what not to do, but also a little bit what to do. But it's clear under these chemicals agreements that a key component is funding. I don't believe just throwing money at the problem will solve the problem, but if you simply do not have the bare minimum of resources, you can't deal with it, right? So if we can deal with many of the issues that Kristin talked about, has to do with if mainly industrialized countries are willing to pony up the money or not.
Actually, I have a question for Kristin and maybe for you guys as well. You said that the treaty specifically mentions in the case of gold mining elimination if feasible, and presumably that would mean because a substitute has been found that works. So do we know if there's anything that has worked at all, and if there's any research on any level that's going on to try and find?
Yeah. So to my mind, and what I gathered from being at one of the negotiating sessions with Noelle and Henrik was that the feasible part, where feasible, has to do a lot with the conditions in the country where the mining is taking place. So there are some geological conditions where it's much easier to use mercury-free methods. For example, in Colombia, the gold is really high up. It's very easy to pan it without mercury use at all. Now, in other places like Peru, you have to use a completely different type of mining technology. It's still small scale, still rudimentary, but that kind of rock requires a lot of mercury to be used with it. So some places geologically it's feasible, and then in other places it's not geologically feasible. So then above that, the feasibility is on the financial dimension. So there are cleaner technologies that exist. For example, if anyone watches Discovery Channel, or there are these shows that are on now about people who have like busted out in the real estate market in the U.S. and they're going down to Guyana to go mining. So what are they using? They're using this really expensive clean gold technology. They have these sluices that are magnetized and they have things to grind it. You can do it without mercury. That's what the large-scale miners do. They use a MacArthur-Douglas process with cyanide. It just costs money. So geology and money are the answers there.
So I just wanted to point out that the control and where feasible eliminate is throughout the treaty, and that was a language. There were certain parties that wanted control and certain parties that wanted eliminate or reduce. So the control and where feasible, it is eliminate in mining, but control and where feasible reduce is language that's throughout the treaty. So that filtered into that section because control or reduce was an area of disagreement.
But just building off both what Kristin said and what Noelle said, right? So both for the small artisanal gold mining and for the power plants, we have the technology to do it largely without mercury, right? It's a question, it is technically feasible. It's just a question whether it's financially feasible, right? So we can do this. We have the technology to do it, right? The scrubbers that work in Europe and in the United States do in fact work equally well in China and India. It's just a question whether the money will be ponied up to put them in there or not, right? So this is actually one of those good environmental problems in that in many of them actually have a technical solution.
The analog is also for dentistry. If the manufacturers have an incentive to make materials that replace amalgam, that's going to solve the equation, and that's it.
Just to connect here, there's also an issue of marketing and acceptance, in that if we call them, dear patient, shall I give you the mercury amalgam? if we simply change the nomenclature, you find a very different response to, no, I'll take the other one, please. These are...
They developed one in Japan. It just didn't work well, but there was a mercury-free amalgam.
So these issues of how it goes everywhere from the miner all the way up to the sort of corporate decisions about expense versus what's going to be marketable, it's a fascinating set of connections that then brings us back maybe to, Henrik, to your point, that there are a lot of analogs to how we deal with this. Mm-hmm. It's a question of identifying them, thinking about money, thinking about where is the affected place. Sierra Leone is tougher to work with. If Somalia had gold, this would be an issue there too, but that doesn't happen to be what's located there. But you look at that map, those are failed states, there are informal economies, and then we fall into the deeper issues that we look at, the longer range kinds of questions.
I mean, we mentioned about, there were some mentions about the consumer pressure, but I was wondering in the trade discussions, the fair mined and the fair traded gold, was there some kind of perspective about getting the consumer pressure on that? I think probably it's much easier to actually get some, help and then money or, resources, through that channel, I guess.
Well, it can be. It also goes back to what Jim was saying about the advertising piece of it. And I think it's an important point to note that, we have more practice as a society in advertising products like jewelry, and we have more, branding and labeling. We have more experience with that. But at the end of the day, you're still going to need a constituency or a cohort that's willing to pay that extra price for the more expensive gold. And it's probably going to be that same cohort of people that are willing to also pay money for the NGOs, to lobby at the treaty and to lobby at the negotiating things, to push for stricter Mercury conventions. So it's a question of identifying that group of people, motivating them, and then expanding it at the end of the day. So, it seems easier because it's more like psychologically available to all of us. We're used to buying things every day. But in reality, when we really think about creating the supply of fair trade gold, it's going to be tough. It's going to be tough.
But for many of the products and industrial processes that are covered in the convention, it's the same story over and over again, right? As in, for all of these products, there are mercury-free alternatives. And for the industrial process, you can produce whatever they're producing through mercury-free alternatives. So this is not about banning products per se, that you can't buy a product anymore, you can't do an industrial process anymore. You just have to do it slightly, have to do it mercury-free. So this is not about reducing products per se from the market or anything like that. It's just, are we willing to do the investment again, right?
Natural gas versus coal, right?
Yeah.
And sometimes it is the marginal investment worth the mitigation of the risk. And one good example of that is complex fluorescent light bulbs. So switching from an incandescent to a complex fluorescent reduces a lot of energy use, and that can be beneficial, including on mercury, if you're getting your mercury from your energy from an uncontrolled coal-fired power plant. Of course, you do have the LED option, much more expensive even for the U.S. So where do you fall on that category? There's a lot of work in the complex fluorescent manufacturers to reduce the amount of mercury per light bulb. And that's sort of where the treaty fell. It said, okay, the ones that have really high mercury, we're going to phase out. The ones that are lower mercury, we actually still want on the market because their benefits outweigh their risks.
So a couple of comments. As an economist, I think, self-interest actually takes us a long way. My recent fillings have not been amalgam as far as I know. They're plastic because of vanity. Vanity can take us very far, right? And on that same self-interest perspective, I think there is a potential comparable here with lead. That almost every country in the world now, I think there are 2 or 3 countries that still have leaded gasoline, but almost every single country, and we're talking 190, something like that, countries have banned lead in gasoline. And that's because they see it as in their own interest to stop doing that. But what preceded that was a global awareness of the effects of lead on development. Countries that you would not think have strong scientific, overall awareness have backed up the idea of getting rid of lead. the same thing can be happening in mercury. But Kristin, you sent me by email an article that's got a picture of monitoring facilities around the world, and there are very few in South America. They're like 2 or 3. One's in Chile, one's in Brazil, right? Whereas we know a lot of this artisanal mining is happening in Peru, it's happening in Colombia. So my question is, to what extent is this Minamata Treaty being paired with funding for awareness and for better monitoring, support for monitoring, and support for education campaigns, so that Peru will see it as in its own interest to make sure that mercury isn't being used in artisanal mining?
So I can answer that a bit. Awareness raising, yes. Public education, yes. Actual monitoring, no. So there is an effectiveness evaluation that might actually sort of enhance some of the research and development on the side, but there's no large-scale funds that can be expected for that in terms of what it takes to set up a mercury monitoring station. A lot of those stations, I imagine, the one that you sent over was funded by the European Union, so individual parties. One issue about the local versus global benefit, and this is something that hasn't really come out in the discussions, but in terms of emissions, when you put the kinds of scrubbers that are likely to be feasible in sort of the India and China context, those are the ones that the U.S. and Europe put in the 80s and 90s on power plants. They're pretty traditional particulate filters, pretty traditional air pollution technologies. They have a lot of benefits for particulate matter, for local air pollution. And in fact, most of the mercury that they scrub out is the kind that falls close to the source. So in terms of, you're probably getting more local benefits than you are global benefits by putting these in. And countries really differ on the extent to which they have realized this is a local benefit issue. And this is sort of a general awareness raising. For example, China is installing these particular technologies by default on power plants. China actually has more of these technologies on power plants than Europe. Whether they're operating or not, that's another thing. But at the installation where they actually, build a new plant, they have so many new plants. They have more plants with that technology. Now they can turn it off, of course. India, on the other hand, is not. And so you have to think really country by country as to what the regulations are. China, for example, 2 years ago set a mercury-specific regulation from power plants. Now it's fairly high. The power plants, even uncontrolled, have not too many problems meeting it. But that awareness is there to actually put that in the legislation.
Yeah, and then in the mining article, there is language in the national action plans where countries are required to say what they're going to do to monitor the sector. But again, it's not very strict. They can interpret that however they want to.
Well, let's draw a close at the 1:30 appointed hour. That clock is wrong.
Oh.
A little bit slow. And thank our panel today for the wonderful seminar.
No, thank you for having us.
Yeah,